All right, today we're going to continue on with our matrices. Now we have two different objectives that we're going to talk about today. First one is we're going to add and subtract matrices. Really rather simple. And not too more difficult is multiplying a matrix by what's called a scalar. We'll go over both of these. There's a key concept for each of them. Let's start with the adding and subtracting of matrices. So here we have adding and subtracting matrices. Notice they have this part here. It says to add or subtract, they must be the same dimension. You can add it, and then when you have that, you add or subtract corresponding elements. So notice this A in the top left and this E in the top left, those get added together, and their answer goes in the top left. Top right with top right, bottom, bottom, so on and so forth. Same thing happens with subtraction. Obviously, we are then subtracting them. So here's an example. The 3 and the 2 are corresponding entries. They are both in row 1, column 1, top left. So 3 plus 2 is going to be 5. So our answer here would have a 5. And then negative 5 plus 0 would just be negative 5. So we have 5, negative 5 on top. And then in the denominator, on the bottom row, we have 1 and negative 9, which would be negative 8. And 7 and 10 is 17. So not too difficult. So let's go ahead and do this. Find A plus B. A is this matrix, B is this 2 by 2. Again, 2 rows, 2 columns. So how do we go ahead and add this? Well, we're going to go ahead and take the first one here, the 6, and we will add it to the negative 3. So 6 with that. We're going to add the 6 with the negative 3. The 4 gets added with the 1, negative 1 with the 0, and 0 with the 3. And then it's just 4 separate little addition problems. Add them together, we get 3, 5, negative 1, 3, and that, of course, is our answer. Let's try another one. We can do a subtraction. But notice the problem here. This is a 2 by 3. This is a 2 by 2. If you remember back from our original key concept, it says you can add or subtract matrices with the same dimension. Now the fact is, this was a 2 by 2 with a 2 by 2, so that was fine. If we look at this one, this is a 2 by 3 with a 2 by 2. We can't do that. And we actually just write cannot do, cannot be subtracted. CND, if you want to for short, cannot do, cannot be done. All right, so look at this one. Again, they want to add. So it's a 2 by 2 and a 2 by 3. Can't do that. Their dimensions are different. What about this one? Well, these are both 2 by 2. We can add those. So let's start with the top row. Negative 2 with 6 is 4. And 3 with 5 is 8. So what 4 and 8 should be the top row. 4 and 8. Well, it's got to be B. Don't even need to do the bottom row, but of course that does add up. 1 and 3 is 4. And negative 1 and 0 is negative 1. All right, second concept, multiplying by a scalar. This is just actually kind of like distributing. So we've got a number on the outside, in this side space is called K. And so we just take that K and multiply by everything on the inside. So negative 3 times 4 and negative 3 times 1, and we just multiply them all. So if I want to find 2A, what I'm going to do is I'm going to take everything in A and multiply by 2. So this top row becomes 4, 2. Middle row becomes negative 2, 6. And then the bottom row is 0, 10. So just multiply everything by 2. And those are the numbers we talked about, giving us our answer. Now, of course, they do a lot of extra steps. Same thing with the subtraction and addition. You want to skip a few steps in there, that's fine. That's quite understandable. All right, so if I want to find 4A, let's talk about the top row. 2 times 4 is 8, 12, and 0. 8, 12, and 0. Well, that's the only one there, so it's got to be B. Now we can do these two operations together. We can do scalar multiplication, 4A. So we're going to have to multiply everything here by 4. And then 3B, multiply everything there by 3. Now we can do it one of two ways. We can either do the 4A and the 3B and then subtract them, or we can do 4A multiply by negative 3 and then add them. Both work. It doesn't matter. You should get the same answer both ways. So let's do the 4 times each of these and the 3 times. Notice it's not -3, it was just 3, so it's still negative here. If you distributed that negative, then this would be a plus. Doesn't matter either way. So this first one becomes 8, 12, -4, 0, and then -6, 3, 0, -3. So we've done the scalar parts, and now we're just going to go ahead and subtract. 8 minus a -6. Please be careful with these double negatives. 12 minus 3, -4 minus 0, and 0 minus a -3. So these double negatives do make a plus, remember. So 14, 9, -4, 3 for our answer. We can even do that in some sort of a problem like this. We have a small company that makes desks and cabinets. Each one requires different amounts of hardware. We have short nails and long nails, short screws and long screws. This is what a desk takes. This is what a cabinet takes. So we can figure out how many of each type we want if we order 3 desks and 4 cabinets. So we're going to do 3 times our desks and 4 times our cabinets. Multiply them out. 30, 18, 24, 12, 16, 12, 32, and 16. Add them together, and so we're going to need 46 short nails, 50 long, 36, and 28. And that could be one way that we go ahead and use this kind of information. And that's what I have for you today.